Alright guys, this is number 6 from 3.7. We're looking at how to find the asymptotes. So to find asymptotes, like I always say, we want to start by factoring if we can. Alright, so I want to factor actually the top and the bottom. The top is going to factor 2x minus 2x minus 1. And the bottom is, they're all divisible by 3. So pull out a 3 first. That's going to give me x squared plus 4x plus 9. Plus 3. Then I'm going to go one step further and factor that to, let's switch colors here so we distinguish our lines. That's x minus 2, x minus 1 on the top, and this is 3, x plus 3x plus 1. Yeah. Alright, and then when you're trying to find the vertical asymptotes, what you want to do is you want to simplify as much as possible. But here, there's nothing in common, right? No factors in common. So that is simplified already. This is my simplified version. All right, I'm going to abbreviate vertical asymptotes with VA. So the vertical asymptotes, there's 2 of them when x is -3 or x is -1. And vertical asymptotes because those are vertical lines, and the equation for a vertical line is x equal to the number, right? In this case, -3, -1. So I'd have a vertical line at -1 and -3. Those are the vertical asymptotes. Okay, now for horizontal asymptotes or oblique asymptotes. Oblique, there's going to be one or the other. You can't have horizontal and oblique asymptotes. And if I look at my original function, x squared, they're the same power, right? So when you have the same power in top and bottom for the highest power, it's going to be a horizontal asymptote at the division of the coefficients. So here there's a hidden 1. So this is like 1 divided by 3. That makes the horizontal asymptote, abbreviating it HA. This is going to be the equation of a horizontal line. So it's going to be y is equal to 1 over 3. Right, this is really just looking at what's going to happen as x goes into infinity. As x goes to infinity, I can effectively ignore these other smaller parts and just focus in on the highest power guy. And then I focus on what is the leading value, because that's going to tell me what the overall function is going to head towards, right? So 1 over 3, because as x gets really, really big, these guys take over times 1 and times 3. Right, so the horizontal asymptote is 1 over 3. That's number 6. That's for when they have the same power. We just take the coefficients and divide them for the horizontal asymptote. Like I said, if it has a horizontal asymptote, that means there's no oblique asymptote. All right, number 7. I have f of x equal to x plus 1 over x cubed minus x squared. Alright, just like before, first thing I always want to do with these guys is factor. Top is already factored. Bottom I can pull out an x. Actually, I can pull out an x squared. Yeah, I can factor x squared. That's going to leave me with x minus 1 in the bottom. Okay, so now I look at this thing. This is reduced, right? And so let's look at our vertical asymptotes. Vertical asymptotes, wherever the denominator is 0. It's 0 when x is 0, and 0 when x is 1. So again, equations of a vertical line, x equal to 0, or x equal to 1. Okay. What about the horizontal asymptotes? Or oblique asymptotes? Well, there's no oblique asymptotes because there's a horizontal one. Whenever the power of the numerator is smaller than the power of the denominator, this denominator is going to overpower the top, and so it's going to effectively go to 0. So y is equal to 0 is your horizontal asymptote. Looks like a line that's right at the x-axis. That's the horizontal asymptote. That's where your graph is going to head towards as you go bigger and bigger. Okay, that's it. So if you haven't yet read the box about these things before looking at the questions, make sure you go back and do that. I'll give you a little more explanation of what's going on. Alright, number 8. F of x is equal to x squared minus 1 over x minus 1. Okay, so this thing, factor, it's going to be x plus 1, x minus 1. And the bottom is x minus 1. Here's a case where we can simplify. X minus 1's cancel each other out. And so in the end, I just get x plus 1. Now, when I look at the final form, not to be confused with the when villains power up until their final form of the. Never mind. Okay, so if I look at this final form of my rational equation, then there's nothing on the denominator, right? The denominator's gone. So as far as vertical asymptotes, there are none. Okay, now let's look for horizontal asymptotes. Horizontal asymptotes, there are also none because the numerator has a bigger power than the denominator. Anytime that happens, there's no vertical asymptote. However, the numerator is exactly 1 bigger than the denominator, right? So that means it's going to have an oblique asymptote. So we'll see O for oblique asymptote. Now this one is a little more involved. How do I find oblique asymptotes? I actually have to do the long division. So I'm going to do that on the side over here. This is x squared plus 0x minus 1, and I'm dividing by x minus 1. Right, how many times does x go into x squared? Let's see, x times, so x, and I'm subtracting x squared minus x. Right, that's, this guy's gone. 0 minus x is, minus negative x is actually positive x. Bring the negative 1 down. And so next is going to be plus 1. Oh yeah, actually I should have known that because this is actually the result from here when I simplified, right? But never mind about that. Okay, so the result is x plus x minus 1, which means minus x minus 1, remainder is 0. Now the remainder actually is not important though. I don't care even if this remainder is something else. The oblique asymptote is going to come from this portion of the division, the long division. So in our case, the oblique asymptote is this equation. Y is equal to whatever the result is before I include the remainder. It doesn't matter that the remainder is nothing. Even if there was something, it would still be that portion, that same portion. So the oblique asymptote is x, y is equal to x plus 1. Okay, that's number 8. Let's go on to the last question. Okay, this time find oblique asymptotes. Find asymptotes for f of x is equal to x minus 1 on the top, x minus 2, x plus 3. All over x minus 5. Oh, this is actually a really easy one. We can skip straight to the answer because it's already factored for us. So let's start with vertical asymptotes. There's only one time where the denominator is 0 and doesn't cancel at the top, so this is already reduced. The asymptote is x equal to positive 5. Now for horizontal asymptotes, if you look at this top part, it has 3 factors. That means you have a cubic function on the top, x to the third something, yeah? So power 3 in the top means it's higher than the power 1 on the bottom, so there's no horizontal asymptotes. As far as oblique asymptotes, the power on the top is 3, the power on the bottom is 1, so they're 2 away, not 1 power away, and so there's also no oblique asymptotes. And that's it. So there's only a horizontal one, x equals to 5. Okay guys, that's it. We're done for today, so have a good day.